In this today's session, we are going to discuss about the ISO symbols of the fluid power. Okay. So first, I would like to explain how can you segregate, how can you differentiate whether the hoses which are related to the pneumatic system or the hydraulic system. This is the symbol to represent the hose, right? Horizontal line. Okay. If you show the symbol like this, the symbol is represented like this. Okay. If it is empty, then it is related to which system? Pneumatic system. Okay. If the symbol is like this, okay, and if it is not filled, then it is related to the pneumatic system. If the same symbol is, if you draw, okay, and if you fill with this arrow, okay, then the symbol is related to which system? Hydraulic system. Okay, that is the main difference between pneumatics and hydraulic system. We have already discussed the difference between pneumatics and hydraulics. For the hydraulics, the fluid is in the form of the liquid, and in the pneumatics, the fluid is in the form of air or the gases. Okay, this is the main difference between the hydraulics and pneumatics. Now, after that, I'm trying to explain the different types of pumps. Okay, different types of pumps using the hydraulic system. Now, if you draw a symbol like this, if you draw a symbol like this, and if you draw a vertical line here, okay, this is the outlet, and this one is the inlet of the pump. Okay, outlet and inlet of the pump. Okay, and if you draw a symbol like this here, triangle. Okay, and if it is fill, then what is the type of this pump? One direction. The type of pump is one directional fixed displacement pump. Okay, one directional fixed displacement pump. Okay, this is the type of the pump. If the arrow is represented in the one direction only, so the type of the pump is one directional fixed displacement pump. Okay, if you draw same symbol, if you show the arrow in the both direction, if you represent the arrow in the both direction, okay, and if you fill this, the name of the this pump is the bidirectional fixed displacement pump. Okay, bidirectional fixed displacement pump. Fluid is flowing in the both direction. This is about the bidirectional pump. Okay, and in the both cases we are having the variable displacement. Okay, if you represent the cross arrow, if you select any one type of the pump, okay, and if you represent the cross arrow like this, okay, if you represent the cross arrow like this, okay, then the name of the symbol is what? The name of the symbol is what? Variable displacement. Okay, this cross arrow indicates what? Variable displacement. Okay, one directional pump. What you have to include just one directional. Instead of fixed displacement, just you have to add the variable displacement. Okay, this is the one directional free displacement pump, bi-directional free displacement pump. Okay, and if you show the cross arrow, one directional variable displacement. Instead of free displacement, you have to use the variable displacement pump. Okay, this is the all about the types of the pumps. Okay, again we have discussed one more case in case of the hydraulic system, that is the motors. Another type or another device which is used in the hydraulic system is the motor. which is the function of the motor is exactly opposite to the pump. Okay, it is going to convert the pressurized fluid power or fluid power into the mechanical power. Pumps are converting the mechanical power into the hydraulic power. Okay, so how to represent the motors? If we show symbol, it is little bit similar to the hydraulic pump, only the direction different. Okay, of showing the arrow at the outside direction, you have to show the arrow in the inside direction like this. This is the symbol for the one directional hydraulic motor. One directional hydraulic motor. If this arrow is not filled, then you can say that one directional pneumatic motor. Okay. If you represent the arrow in the both direction, it is similar to the pump. Okay. It is the bidirectional. Okay. If you represent the arrow in the both direction, you can say this is the bidirectional. This is the bidirectional hydraulic motor. Okay, this is the symbol for the bidirectional hydraulic motor. And this is clear up till now, hydraulic motor and the pumps. Now the next type of the symbol is the actuators. The next type of devices which are used into the hydraulic system and pneumatic systems are the actuators. Now how to represent the actuators? Actuator is a device which is having the two types. One is the linear actuator and the rotary actuator. Okay. If you draw a symbol like this, if you draw a symbol like this, if you draw a symbol like this is called as what? Here you have to show one inlet port, inlet or outlet port. Okay. This is called as the single acting actuator. Okay. This is called as the single acting actuator. Single acting actuator. Now another type of actuator is the double acting actuator. Again, there are more types in the single acting actuator. Okay, here spring is also installed. Okay, if the symbol, if same symbol is there, same symbol is there. If you are adding the spring here, if you show the spring like this, the name of the symbol is what? Single acting spring return, single acting spring return actuator. It is extend because of the pressurized fluid and return to the initial position because of the spring force. So single acting spring return actuator. Here we have shown the port in the one side only, one side of the piston only. If the ports are available on the both sides of the piston, okay. If you show the ports like this on the both side, okay. If you represent the ports on the both sides of the cylinder, then it is called as the double acting actuator. Double acting actuator. These are the basic three types of the actuators. Okay, single acting with spring return, double acting actuator. Okay. Now, if you again like this, you show cross arrow here. if you show the crossover, if you show the again box like this here, okay, if you show the actuator like this, okay, then what is the name of this actuator? This is the double acting actuator, okay. This is the double acting actuator with cushioning on one side, okay. This is a double acting actuator with cushioning on one side, okay. 1 minute. If the square boxes are on both sides of the piston, then you can say that double acting cylinder with cushioning on both sides, okay. Instead of one side, just you have to represent it the both sides, okay. Instead of one side, you have to just mention that. 1 minute, adjust it. Cushioning on the both side, double acting actuator with the cushioning on the both side. This is the symbol for it. If you draw cross arrow again here, okay, in this case also we are having the variable displacement cushioning. If you represent it like this, okay, here if you show the cross arrow here, okay, if you represent here the cross arrow, then what it indicates? Double acting actuator with cushioning on both side, okay. Here you can say that variable cushioning, special word, okay. Cross arrow indicates the variable cushioning. Double acting actuator with variable cushioning on both sides. Okay, these are the different types of double acting cylinder. Okay. Again, here we are having the one special cases in the double acting cylinder. Okay, I will show you it. If the actuator symbol is like this, okay, if the actuator symbol is like this, sorry, okay, and the two ports are available here, okay. What is the name of the symbol? The ports are available in the both sides, so it is obviously double acting cylinder, okay. But what is the name? Double acting actuator. Double acting actuator with rod on both sides. Double acting cylinder with rod on the both side. This is the symbol for the another type of the actuator. Okay. And this is also called as the double piston rod. Okay. This is all about the actuator. Okay. I hope all of you get clear idea about it. How to represent the direction control valve for the sorry, uh, how to draw the symbol for the pumps, motor and the actuators. Okay. Now I am trying to show the ISO symbols, how to represent the ISO symbols for the directional control valve. Okay. directional control valve. Okay, for this, how to represent the ISO symbols. Okay, now if you look at here, in each direction control valve, we are having one position, two position, or the three positions, means on-off condition, neutral condition. Okay, likewise, different positions are available into the direction control valve. Okay, so each position is represented with the help of the box. This square box represent positions. Okay, the square box represents what? Positions. How many positions are available into the direction control valve? And the arrows. Okay, here you are going to show some arrows. Okay, you are going to represent some arrows. Okay, that indicates what? That arrows indicates direction of the fluid flow. Okay, direction of fluid flow, or you can say the path. Paths, or you can say ways. Okay, direction of fluid flow. Okay, paths or ways. Okay, now if I draw the symbol, okay, I will show you one example how to read the direction control valve. Right now the direction control valve is having the two positions, right? This is your first position. Okay, this one is your second position. Okay, if you show the arrow like this, if you show the arrows like this, if you represent the arrow like this, okay, it consists of uh, two positions. And how many ways we are having here? So this is the actuated position. You have to show the arrow like this. Little bit extension. Which position is by default actuated? So this one is your port A. Okay. This one is your port B. This one is your port P. This port is T. P stands for the pressure port, okay, which is connected to the pump. T stands for the tank. The fluid is returned to the reservoir. Port A is connected to the fluid is passing to the front side of the piston, and port B, which is connected to the rod side of the piston. Okay. So how can you label this direction control valve? Okay. So here we are having how many positions? Two positions. And if you count here, how many ways are present here? How many ways, or how many? Here we have written, right? How many ways and how many paths are available here? So if you count here, A, B, P and T. Total how many ports we are having here? Four ports. Okay. Total we are having the four ports. Okay. And how many positions we are having here? Two positions. Okay. So the name of the symbol is what? 4 by 2 direction control valve. Okay. In a simple word, what is the type of the direction control valve? 4 by 2. Okay. 4 indicates what? Number of ports. Okay. 4 indicate number of ports. Okay. And 2 indicates number of positions. Okay. 2 indicate number of positions. Okay. This is how you can draw the different direction control valves. Okay. If I actuate the direction control valve with the help of any external device, okay, Suppose if I draw a symbol like this, okay, I'm going to actuate the direction control valve now. Suppose if I actuate the direction control valve like this, okay, if I show the symbol like this, okay, and if I show the spring in this direct side, okay, because of the spring force, it is returned to the initial position, okay, because of the spring force, it is returned to the initial position, okay, and because of the lever, we are going to actuate the second position. By default, first position is actuated, okay, and if you actuate it, second position is going to actuate. So what is the name of this direction control valve now? 4 by 2. It is operated by the lever, okay, so lever operated, 4 by 2 lever operated spring return direction control valve, okay, 4 by 2 lever operated spring return direction control valve. Same symbol I have written, okay, just I have operated with the help of lever, okay. There are different types of actuating method for the direction control valve. One is the lever operated, roller operated, again the detent operated, solenoid operated, okay, means you have to just instead of lever, okay, instead of this lever you have to show the different symbols, okay. If you show, if you represent the actuating method like this, okay, this is called as the solenoid operated. These are the different ways to represent the actuating methods of the direction control valve. This is called as the solenoid operated direction control valve. Instead of this, if you represent the symbol like this, and if you actuate it with the help of, if the symbol is like this, okay, this is called as the push button operated, okay. What is the name of the symbol? Push button operated direction control valve, okay. Again, if you represent the symbol in other way, if you represent like this, if this arrow is blank, then it is related to the pneumatic. Okay, if this arrow is blank, it is related to the pneumatic. So it is the pneumatic operated direction control valve. We can say the pilot operated. Okay, the name is actually pilot operated. Pilot operated. Pilot operated direction control valve. Okay, actuating method is the pilot pressure. Okay, but if it is the field, then you can say that the pressure line is the hydraulic. If it is blank, then you can say that it is the pneumatic. Okay, here I have just sorted few types, okay, by which you can actuate the direction control valve. Now again moving towards the direction control valve, okay. If I represent the direction control valve like this, suppose this is my first position, this is my second position and the third position. This is my first position, second position and third position. Now, what is the name of the direction control valve? This is the, how many ports are available here? 4 ports. How many ways are available here? How many positions are available here? 3. Okay, 4 ports and the 3 positions. So this is the 4 by 3 position direction control valve. Okay, 4 by 3 position direction control valve. No need to note down the ports and weights or the positions. Okay, so you can directly note down 4 by 3 direction control valve. If it is operated by the, we can say, if you represent it like this, okay, then it is called as the roller operated. Okay, this is the roller operated. Okay, so name of the symbol is what? What is the name of symbol now? 4 by 3. I will delete this. So what is the name of the symbol? 4 by 3 roller operated in return direction control valve. Okay, 4 by 3 roller operated spring return direction control valve. Okay, this is how you can designate the or remember the ISO symbols related to the hydraulics and pneumatics. Now we are having the different types of center position. Now in this case, which one is the center position? This is your first position, this is your second position, and this one is third position. The second position is called as the center position. Center position of direction control valve. Okay. Right now, what is the center position of direction control valve? The center position is right now closed. So you can also include this position in your direction control valve. Center position is closed. 4 by 3 roller 4 by 3 roller operated direction control valve. Okay, having the center closed. Okay, with spring return. So based on the center position, there are again direction control valve is classified into different types. I am just going to show here the different center positions of different center positions in direction control valve. Okay, different center positions in the direction control valve. Okay, here I have shown the close position. Now another type of the position is the this portion T. This is the T inverted T symbol indicates the close position. Okay, inverted T symbol indicates the close position. Okay, and this is a type of direction control valve having the tandem position. You can see that. Okay, tandem center also. Okay, tandem center. Okay, this is the tandem center. My spelling is mistake. Okay, tandem center. Again, if you draw the symbol like this, if the symbol is represented like this is called as the regenerative center. Okay, later on we are going to discuss in the brief what are the significance of these different center positions. Okay, this is called as the regenerative center. Okay, if the symbol is like this at the center of the direction control valve, we are going to discuss all these related to the center position of direction control valve. If the symbol is represented like this, okay, then it is called as the fluid center. Okay, direction control valve with the fluid center. Again, If the center position is like this, this type of direction control wall is called as the open center. Okay. So these are the different center positions of the direction control wall. Okay. I hope all of you are able to understand what I am trying to explain here. Now, this is all about the direction control wall. Okay. Now, moving towards the different types of flow control walls. Different types of flow control walls. Okay. Here we have covered the motors, pumps, actuators, direction control wall. Now, another important component of the hydraulic and pneumatic system is the flow control wall. Okay. The general symbol to represent the flow control wall is like this. Okay. This is the horizontal line. This is like the nozzle like. Okay, this is called as the symbol for the flow control wall. Okay, this is the symbol for the flow control wall. Okay, if you represent the cross arrow again here. Okay, if you are representing the cross arrow here, then it is the variable flow control wall. Okay, variable displacement flow control wall. This cross arrow indicates what? Variable displacement flow control wall. Okay, if you are showing the vertical arrows here, okay, if you are representing the arrows like this, okay, this is called as the pressure compensated. This vertical arrow indicates what? The pressure compensated. This cross arrow indicates for the variable flow. This vertical arrow indicates the flow control wall with the pressure compensated. Okay, pressure compensated flow control wall. Okay, pressure compensated flow control wall. Okay, if you show again one more vertical arrow or one more vertical line, okay, and if you show the symbol like this, okay, this is the symbol for the temperature. Okay, this is the symbol for the temperature. So what is the name of this flow control wall? What is the full name of this flow control wall? Flow control wall with pressure and temperature. Flow control wall with the pressure and temperature compensation. Wait a minute, I will tell you the symbol. Flow control wall with the pressure and temperature compensation. Okay. This green color indicates the for the pressure compensation. This blue color indicates the temperature compensation, and this cross arrow indicates the variable. Okay, variable flow control wall. This is how you can represent the flow control walls.